So what is it that I have to do? So when I say convergence, basically I should see what is f of xt plus 1 compared to f of xt, right? If I see the improvement, if the improvement is, there is always an improvement, and the amount of improvement goes down, well, that's a sequence which is like Cauchy or going down, and it will eventually hopefully go down to 0, right? So that's what we need to see, right? But in other words, I need to check what is f of xt plus 1 minus f of xt, improvement, right? So I have to write an equation that relates these two, right? So let's look at this. So f of xt plus 1, and I have f of xt here. So what is the relationship? Can somebody tell me? Huh? It won't be equal, right? If it is equal, then you stop at 0 itself, x0 itself, right? So what is the relationship? So f is convex. The moment I say convex, what is it that you will write? Huh? Okay, so can we say something more? Okay, so before this, let's also make an important assumption. Assume the Hessian of f of x. So if it is convex, what is Hessian of f of x? It's greater than or equal to 0, right? If it is strictly convex, it's greater than 0, right? I mean, nowhere it can be, right? What other? So suppose I say that this is greater than or equal to some lambda times identity. Do you know what this means? What do you mean by a greater than or equal to b? It means a minus b is greater than or equal to 0, right? Right. Similarly here, what I mean by this is I take this matrix, I subtract lambda times identity, I get another matrix. This matrix is positive semi-definite. That's what it means. Fine. Okay. Fine. So now let's write this. So this is equal to this plus, I can do remainder form of Taylor series, xt plus 1 minus xt transpose times the gradient of f at xt plus 1 by 2 times xt plus 1 minus xt transpose the gradient of f at some x star, sorry, Hessian, right, not gradient, times xt plus 1 minus xt, right? What does that mean? Okay, so now let's look at an aside here. Okay, so a greater than b. What does this mean? This means a minus b is greater than 0. What does this mean? This means you take any x transpose a minus b, x is greater than or equal to 0, right? This means x transpose ax minus x transpose bx is greater than or equal to 0. This means x transpose ax is greater than or equal to x transpose bx. Do you agree? This is true for every x, right? This is what we have. Now, what do we have from here? Well, I can think of this as x. It's x transpose some matrix times x. But this matrix is greater than or equal to lambda I, right? I can think of this as a matrix, this as some x. So x transpose ax is always greater than or equal to x transpose bx. What is x transpose bx? Lambda times identity, right? So I can replace Hessian by lambda times identity. What do we get? Greater than or equal to, right? F of xt transpose, I have lambda, okay, this is gradient, right? Plus half times xt plus 1 minus xt transpose. So a will be identity, right? It will be lambda times identity. So what will happen? Lambda will come out.